Let us have some kinetic energy problems. A cheetah that has a mass of 72 kilograms runs at its top speed of 93 kph or 25.83 meters per second. What is the kinetic energy of the cheetah? In this problem, we are asked to calculate the kinetic energy of cheetah. To solve this, the given are mass, which is 72 kilograms, and velocity, which is 25.83 meters per second. The working equation that we will use is Ke is equal to 1 half mv squared. We have the mass and the velocity, and therefore, we are free to substitute the values in the equation. 1 half multiplied by 72 kilograms multiplied by 25.83 meters per second is squared. The computed volume will be 24,018 joules, which is the kinetic energy of cheetah at its top speed. Let us have another example. While flying on his way back to Earth, Superman has a kinetic energy of 1 million joules. If he weighs 150 kilograms, what is his velocity? It is clear here that we are looking for velocity, right? The mass and kinetic energy are both given in the problem. Then, we will arrange the equation in finding kinetic energy to find the velocity, as V is equal to square root of 2 times Ke all over mass. Now that we have derived the formula, we will simply substitute the values and then perform the integrated operations. Then, the velocity of Superman upon returning to Earth is 115.47 meters per second. For this last example in this lecture, I will let you do this. A slimy hot dog of a mass of 5 kilograms is being moved on a frictionless floor by a constant force of 8 newtons. Starting from rest, it traveled 5 meters across the surface of the floor. What is the final velocity at the end of the 5-meter displacement? Again, I will pause this video and try to solve this problem. Okay, let us see if we get the same answer. In this problem, you are to determine the final velocity of the hot dog. Given the problem are the mass of the hot dog, the initial velocity of the hot dog, the displacement traveled by the hot dog, and the force on the hot dog. To get the velocity, we will use the same formula as we used in the previous example. Square root of 2 Ke over m. However, there is no Ke given in this problem. But we can identify work by multiplying force and displacement, right? Which are both given in the problem. Okay, now that we have identified our equations, let us solve this. Solving for work first, W is equal to 8 newtons multiplied by 5 meters. This will be equal to 40 joules. Next, we will use this value to get kinetic energy. Substituting these in our derived equation along with mass, our computed final velocity is 4 meters per second. And this is the final velocity of the hot dog after traveling a 5-meter displacement. Before we end this video, please remember that kinetic energy is the energy in the form of motion. An object in motion possesses kinetic energy, while a motionless object has zero kinetic energy. The lowest possible kinetic energy of an object is zero. Hence, we can say that there is no negative kinetic energy. At speeds near the speed of light, the kinetic energy of an object approaches infinity. This kinetic energy is called relativistic kinetic energy. In the next video, we will discuss another form of energy, the potential energy. If kinetic energy is energy in motion, can you still remember in your previous science lectures what is a potential energy about? Let us find out in the next lectures. Again, this is Gilmer Di Castro, and see you in the next video.